Hello, everyone. Good morning, good afternoon, good evening, whatever time zone you are. Very warm welcome to our first Bay Area Apache Spark Meetup, kickoff of 2025. We're delighted to have this meetup revive again. This is going to be our first one for 2025. We plan to have a regular cadence of these Bay Area Apache Spark Meetup on a regular basis, talking about all things Spark, and especially the next one, which is going to be exactly a month from today at 9:30 a.m. So if you're a part of the Bay Area Apache Spark Meetup group, I urge you to go ahead and join in so you can actually get notifications on a regular basis of all the events about all things Spark, especially with Spark 4.0, which is coming up soon. So join the group and get connected. So I'm really, really super excited to have my esteemed speakers today. We actually have Martin Grun, who's our principal engineer here at Databricks and the Uber tech lead for Spark Connect, among many other things he has been working on. So he's going to tell us and share us all about Spark Connect, why you should use it, when you should use it, and what are some of the benefits, and how it has evolved over the period of time with upcoming Spark 4.0. So you get to hear from the horse's mouth today. So it'll be great to actually have Martin share with the community all about Spark Connect, followed by Steve Russo, who is the data engineer, and he wrote the first Rust client connects for Spark Connect. So if you are a big fan of Rust programming language, which is really gaining a lot of momentum among DevOps people, you can actually use his Rust client to connect to Spark. So he's going to share us about his experiences about using Rust client. And last but not least, I have Ed Elliott all the way from UK, and Martin from Berlin, and Steve from Connecticut, Cincinnati, corrected myself. And Ed is going to tell us all about .NET. So if you're C# and you love that and you want to connect to the Spark using .Connect, Ed is going to tell us all about it. Now, I have Carly in the background who has just been incredible in doing all the logistics and getting us all live across the globe in all the different channels. Now, just a quick format for today's, we're going to have all the speakers speak first because of the fact that we actually only have about an hour. So each of them will talk about 15 minutes. And then the last 15 minutes I'll reserve for the Q&A and I'll moderate those. So keep your questions coming in the Q&A, and then we'll try to address them accordingly. So with that said, I'm going to hand it off to Martin. Please take it away and tell us all about Spark Connect.
All right, awesome. I'm just going to wait for the slides to appear here magically so that I can advance through them. So yes, hi, I'm Martin. I'm principal engineer at Databricks, and I've been working on Spark Connect now for, I want to say almost 3 years, or like 2.5 years, something like this. It feels a long time. And I think it's a good one to just start a little bit with like, how did all of this start? And I think like what I'm going to do today is, mostly talk about, like the big motivations why we worked on Spark Connect. And I will touch a little bit on like some of the recent developments, but I think it's just always important to remember, like why we were building Spark Connect and why we believe this is a big thing, for the community as a whole. So again, all of this started with this BIP about Spark Connect. And the reason why we started this BIP is that if we look at Spark, essentially in many cases, Spark is associated with like with data centers, large clusters and everything. And over time, people have built like tens of hundreds of different applications on top of Spark that runs in like in many different shapes or forms, like from small clusters to big clusters and everything. But everything is always packaged essentially as one big, application. And if you zoom in, like in Spark's system, the way that Spark works is like everything is consolidated on this monolithic driver. So this is not just, like the distributed execution engine, the scheduler, the optimizer and everything, but it's as well all of the business logic. Everything gets framed and packaged together in one different, in one, monolith. And the problem is that as, evolution has come, essentially, like we see that these data applications, the way that we're using, Spark is no longer just in the data centers. Well, I think like many of the folks out there like still use like Spark a lot for, typically ETL processing, but there are so many other use cases these days, like I want to develop my Spark job from my IDE. I want to connect to a remote system. I want to use Jupyter. Like I have these edge devices, I've talking to customers that want to bring this in, from their kind of like IoT devices, like ingesting data, reading data from Spark. And then the fundamental question is like the JVM still the de facto perfect language for everything? And, obviously, we all love the JVM, but, probably it's not always the right answer. So if I want to use Spark from an environment that is not JVM connected, it's going to be hard. So essentially what we're seeing is that if I want to embed Spark in an application, then I run into a bunch of issues. Well, so if I want to embed this into, my modern, like what we call modern data application, web apps, single page apps, Flask, something simple, I can basically just do SQL. If I want to use it for my IDE on a notebook, I essentially have to bring all of this notebook logic very close to my Spark driver, because that's the only way to connect to it, because even the Python process runs as part of Spark. And if I use a programming language that doesn't come with a JVM interop, I can't do anything. And I think like a very good example for this is, Go, because there's, Rust as well, but, Python has Py4j, I think Ruby has, JRuby. And I think, but Go is one of these languages, for example, that doesn't have any kind of JVM interop. And I think this shows like, hey, how do I write a Spark application in Go? And I'm currently maintaining the Spark Connect Go connector. So yes, I'm like highlight this a little bit. So sorry for that. But I think it's kind of an interesting programming language. And I will talk about this in the end a little bit. So in addition, like how do I run, like if I have multiple users running, like on one Spark cluster, I don't want to spin up one Spark cluster for every notebook that I'm running. I want to like share my compute. And how do I do this? I run into, how do I handle out of memory situations? Like how do I decouple the dependencies that every application brings? The other part that's always a big challenge in Spark is upgrade. So how do I upgrade my, my ETL job from one Spark version to the next one? And like today, everything is like tied together. The class path of my application is tied together with Spark, is tied together to all of the APIs that Spark brings with. Like how do I observe and how do I debug? And so here's where we introduce Spark Connect. So what Spark Connect does is say, okay, we want to bring the full power of Spark via a client API to essentially allow all of these application types to connect to Spark in a seamless way. The way that we achieve this is to say, okay, we took a step back and said, okay, let's look at the way, how do the vast majority of users interact with Spark. And essentially what they do is they use the data frame API. Well, it was introduced, I think, like very early days of Spark, the earliest APIs in Spark was the RDD API, very imperative, basically operating, stringing together different operators. And the data frame API was like, hey, Spark SQL, take a step back, declarative logic of how do I reason about my data processing. It's very comparative to a SQL in general, but like from a structured API perspective. So users use, Spark read tables, select, write into, filter, and all of these kind of structured APIs. And we said, okay, can we translate this into something that is abstract enough that it can be processed by the engine without really having to know everything and without parsing SQL either, because much of the data frame API is structured APIs. So we translate this into what we call unresolved plans. These unresolved plans are essentially a very easy way to essentially combine together all of the data frame operations. And this is then translated into Spark's logical plans on a server. It runs all the way through the analyzer, optimizer, scheduler, and the execution engine. And then we stream back the results, back to the client using gRPC and Arrow. And this is essentially like a very convenient way to connect this back to all other systems that speak Arrow. I think like Steve has been using the Arrow implementation to connect this back to data structures directly in Rust. In Go, like I can use the Go Arrow library. In Python, I can like even bring this to Polars. Like every system that speaks Arrow can essentially understand the data that is returned back, which is great for the interoperability. All right. And so essentially what I get with Spark Connect is, this kind of this thin client everywhere. Well, I can get the power of Apache Spark everywhere. No matter what programming language I use, no matter from where I'm connecting, I can use this. However, it is kind of important to mention that, you could say like Spark Connect has connect in name, and because of that, connect means remote connectivity and all of this stuff. Yes, that's awesome. But like Spark is still, again, as I said, like ETL is a big chunk of it. But there's still like a lot of problems that, Spark Connect solves in this area as well. And I just want to highlight again, like upgradability. As we are now reaching, like the Spark 4 kind of release, it's again a question like, okay, what is the cost of, upgrading my Spark application to the next Spark release? What is the cost of upgrading my Spark release to the, 4.1, 4.2, and so on? The way that we designed the Spark Connect protocol was explicitly in mind with backwards compatibility to the client. So if I have compiled my code, my Scala code as well, against the Spark SQL API in Spark 4, it will seamlessly work against Spark 4.1, 4.2, 5, and whatsoever. Because the dependencies is no longer, some serialized JVM structure, some like private APIs that are exposed in some jars. No, it is the protobuf definition, which makes it very, very compatible and it's a very standard way of interacting with the system. All right. So now I want to talk a brief moment about like, hey, what does it mean like Spark 4 with Spark Connect? So, like when I was doing these slides, I was asking myself, okay, so like, do I actually have to care about like Spark Connect in the context of Spark 4? And I said like, well, care sounds like a little bit mean. So let's ask like, do I have to know about Spark Connect? And fundamentally, the answer is no. Like you should not have to reason about this. As long as you're using data frames, this is the right way to use Spark. Declarative data processing logic, writing using data frames is the right way of using Spark. And like using Spark Connect is just something that might or might not happen behind the scenes. And the biggest benefit that comes with the Spark 4 release or the upcoming Spark 4 release is essentially the fundamental parity between Scala and Python on the data frame API in Spark 4. This means no matter whether or not your workload is in Scala or in Python, you can use or not use Spark Connect transparently and you don't have to worry. And I always get to ask like, but what's then the benefit? Like if it's completely transparent, like why do I care? And I think the one of the biggest benefits is like, and this cares again for the ETL applications, dependency isolation of the client job. So if I can run my code, I can have my own class path. I don't need to deal with like, did Spark change something? Is my dependency that I'm using in my ETL driver, is it different than this that Spark uses? Like Guava is, this magic carrot that we talk all about. And it's like, hey, no, it can be different. And the same goes for upgrades. I make upgrades a lot easier. And essentially our goal was like the Spark Connect is part of Spark 4 release was essentially to guide users to make sure that we want to guide them to using the declarative data frame APIs in Spark. We want to simplify upgrades and maintenance of Spark applications and carefully nudge users toward using Spark Connect, even if they don't care about the connect part of Spark. Well, we achieve this by, having this full parity between Python and Scala. And there's, one Spark conf to rule them all. Like there's essentially, one Spark conf that you can flip in Spark 4, like from Spark API mode from Classic to Connect. And then you're using Spark Connect and you don't have to worry. There's nothing else to configure and then off you go. And the coolest part is if your work runs, on top of this, you get this extra, which is the remote connectivity. And this is essentially where, like, which brings all of this additional stuff to Spark, that wasn't there yet, like connecting to a remote machine, building like new kinds of applications on top of Spark. But again, I want to highlight something. This is maybe a good segue as well to Steve's talk and Ed's talk is essentially about, I've been thinking about like as a maintainer of the Spark Connect Go client, it's not just about basically connecting remotely to Spark and building new applications. So for example, I've been trying to figure out like why do some users prefer Scala for writing ETL jobs? And the usual answer that I get is, oh, it is a typed language, it compiles and everything is safe. And I think, like, well, that's true, but why can't I run a Spark job in Go? Well, it's a compiled language. It's like the syntax is very simple. It's like very much similar to Python, but it's compiled. And it's like the even better part is it is a static binary. All my dependencies are completely compiled into the application. And now this is something that I wish we would have had time for Spark 4, but I think it will come in Spark 4.1, is, Spark submit a binary that talks to the local Spark Connect server and runs as an ETL job. And all of the reasons and all of the challenges that we sometimes face with, like the JVM as the host language for the driver, they're alleviated because it gives the users the flexibility to bring the ETL jobs and the data processing in the language that they're most familiar with to Spark. And I think that's a huge benefit. And, like just to highlight one other language that got a little bit of attention in the Spark land is Swift. So there's an open source contribution by Dongjun, who's been publishing this Spark Connect Swift client. And, I've been using this to build a Mac app to run queries against my Spark clusters. And it took me, maybe an hour using ChatGPT and perplexity to generate enough code to make it work. And it's amazing. I mean, like, this is so cool that I finally have my native Mac app speaking Spark. I mean, that's just mind-blowing. All right, so enough fanboying about like why Spark Connect is awesome. I think now it's time basically for Steve to take over and talk a little bit about Spark Connect and Rust, essentially. Thank you so much.
Thank you, Martin. That was a great intro to pass through onto this, especially talking through some of the things you can kind of do with this. So as Martin was saying with the new Swift one, one of the things I was focused on was kind of like trying to figure out how you can write native Rust code, but then connect to that Spark, remote Spark cluster. So before Spark 3.4 came out with Spark Connect and evolved a lot with 3.5, Spark was kind of always on the outside looking in at the data ecosystem that Rust was building, and was building quite fast. I know I'm missing a whole bunch for the logos on this slide, but the ones that always come to mind are Polars, Arrow, the Delta Lake implementation within Rust, Data Fusion, and also Data Fusion Comet, which brings Data Fusion into the Spark execution engine, which is a really cool project. And even ones I don't even mention on here, like Iceberg is another one that's out there that's implemented with Rust, and then a really interesting one. Lake HQ has a sail library that actually is the reverse. It implements the Spark Connect server in Rust, which is a really interesting project too. But with this client specifically, I wanted to focus on how would it look like to use that native data frame API with Rust, and like what were the attributes of Rust that you would want to leverage with this. So the way this is kind of built out, you don't even need to really understand how to write Rust code, but if you've written a Spark code before, this should look very familiar. You're creating your Spark session, you're connecting to that remote cluster that you have, you're reading data into a data frame, you're selecting all those options. But additionally, what this crate has is those other Rust elements that the Rust developers want to have, so like enum support, traits, all the safety of the Rust system is still within this overall crate. So that's one of the things that you can have with this. So now I can write my whole Rust program. I can write my whole library that I want to build with Rust, but I can then guarantee that what I'm working with is still within that safety, which is Martin was talking about with the Go implementation. So the overall goal with this was to kind of like write out what it would look like to mirror that same data frame API, but with that same syntax to make sure that those Rust developers can leverage those different parts. And then it kind of, as Martin mentioned too, was like, well, where would you really want to use this? With Rust, you're going to build that really tiny library, that really tiny execution file, or that executable, and you're probably going to deploy that somewhere. You're going to push that somewhere. So in the case of this simple example, you have your Rust developer writing their code that gets pushed to a library. They make the pull request. The build library builds that image. It sends it to the registry. And then their target, in this case, it could be AWS Lambda, it could be edge devices, it could be any number of things where like size could be a really big constraint. So then that just pulls that image and it runs that really tiny executable file, but it's connecting and offloading all of the big processing to the remote Spark cluster. So it's talking with that protobuf call, sending that unresolved logical plan to the Spark cluster, and then the Spark cluster is responding back with those record batches in Arrow. So the overall target doesn't need to be that driver anymore. And you can kind of pick the language that you want to use for these cases as we're kind of building out other ones. So Ed with .NET. I think there's also JavaScript one. I've played around with that too. That's kind of being out there if you want to kind of use that language for it as well. But like this kind of gives that whole new way of interacting with a Spark cluster from the language of your choice. And since the data frame API kind of like builds all that around there, you kind of have that expected syntax when you kind of start to then leverage these different clients. So kind of building on this little deployment example, I am not bold enough to do a live demo. So I recorded myself on this because Murphy's Law would say that the live demo would not work. So I recorded myself doing this. So what this contrived example is I'm running a tiny little Rust job on my computer. And it's just collecting system stats from my computer. So you could think of my computer essentially as like an edge device. It's collecting like the CPU usage, the temperature, the name of it, and it's going to connect to the Spark cluster remotely and potentially join with, in this case, maybe a predictions table that already exists on a remote state, or maybe it's running some type of other thing on the Spark cluster to join with some other larger table that my little tiny edge device couldn't handle in memory. So this is just running that little example. And also, as Martin mentioned, the big thing about observability. So now I'm kind of hard to see a little bit, but I'm logging certain information on the client side about this overall processing. So I'm increasing the observability, and what I'm printing out right here is just the brand, the uptime, how long my computer's been running for. But then as I join with that system state table that I created on the Spark cluster side, it's pulling in like the location of it, if my computer is acting in an anomalous state, or the predicted CPU usage. So in this case, this is where those edge devices really come into place, where you are constrained by size. Like you want to be deploying and running things elsewhere, but your Spark cluster, your catalog has data that you want on that edge device. You can kind of just call out to it and go get that data back and then render it. So then the example kind of like scrolls through, and it kind of keeps doing that every 5 seconds. And then on the other side of this, you can kind of see what the my remote cluster is running, which is just it's just a Docker container with Connect running on the background. So it's kind of just dumping out all those results as it kind of goes through. But with Rust, you can also compile to like a bunch of different other targets too. So if you really wanted to take this forward, and this is where I'm looking for some help on some contributions, you can even get really clever with this and compile to like a WASM image, or so like WebAssembly. So this is actually an example that I had working at one point that is using WebAssembly and running a Spark job in the browser. There is a little trickery to this. You do have to have kind of a proxy server involved to handle that gRPC web interface. But you can kind of then take everything that you like about the Rust ecosystem, and then if you have this compiled image, you can kind of change your target, and you can deploy a lot of these different Spark jobs to different things, with obviously the constraints in mind. Kind of deploying to a WebAssembly image, it can be quite tough, especially with some constraints that are out there. But I really just wanted to give, right before I pass over to Ed, just a shout out to the contributors that have helped on this. They keep me honest. They definitely press me for more features, and I really appreciate it. Some of them are in the chat. Thank you so much for guys for contributing to this stuff. But I wanted to pass it off to Ed next to talk through about the great stuff he's been doing with .NET.
Great, thanks, Steve. Really interesting to see Spark running in the browser. That was great. So for .NET, I'm going to speak a little bit about the history of .NET, because before Spark Connect, there was a couple of projects from .NET where we could connect to Spark, just to sort of talk about them, and I'll talk about what you can do today, what libraries are available, and what options you've got for connecting to Spark from .NET. So if we start back all the way in 2016, there was a project called Spark CLR, or Mobius, which allowed you to run .NET code against Spark, and this worked by deploying a jar onto the Java virtual machine, creating a network connection, and then the client would connect to that, and requests would be proxied backwards and forwards. And this is our first way that .NET developers could use Spark. That was deprecated and then replaced with the .NET for Apache Spark project in 2019. And this had a team behind it at Microsoft. It actually got quite far. So this was deployed to Microsoft's implementation of Spark, hosted implementation on Synapse Analytics. And we had notebooks that would support PySpark, Scala, SQL, and C#. So we were sort of first-class citizens. Then we sort of rolled forward a couple of years, and Spark Connect was announced, which was going to be this supported API for connecting for other languages. That was really exciting. And then around sort of late 2022, the Spark project, the .NET for Apache Spark project, slowly PRs weren't being reviewed, issues stopped being commented on, and sort of later found out that the core team left Microsoft, and there wasn't really anyone to maintain it. And also coupled with the fact that the adoption on Synapse Analytics for .NET hadn't been as high as Microsoft had sort of hoped, so the team wasn't replaced, and it was a sort of it ended up being a block on what we could do using .NET, and it was a real shame really, because I spoke to a couple of teams who wanted to use .NET, but the current state was we couldn't use the project, we couldn't really extend it, or if you wanted to take it forward, you'd have to build the project yourself. Then in 2023, Spark Connect went GA, which was great. On the .NET side of things, we had some discussions about migrating the project over to the community, but those discussions didn't really go anywhere. So I created Spark Connect.NET, which is a data frame API around the Spark Connect interface, which allows us to connect from .NET using the supported Spark Connect API, which is great. And then towards the end of 2024, there's a couple of contributors that have appeared back in the .NET for Apache Spark project within Microsoft. So potentially at some point that might migrate to Spark Connect as well. So we've got a couple of options. So it's definitely an exciting time for .NET and Spark. And finally having this supported interface is really good and really helps us. So this is the state of the current project. So Mobius Spark CLR, that was deprecated in 2017. It's used the Java approach, supports Spark like 1.4 up to 2. And we've got the .NET for Apache Spark project. Again, also uses the Java and network connection approach. It's currently being maintained, but we haven't had the release for a while. And then we've got the Spark Connect library, which I've created, which supports Spark 3.4 upwards. And because it uses that Connect interface, it will support Spark 4.1, 4.2, whatever future ones there are. That's currently being maintained, but as sort of Martin said earlier, like the architecture is it will carry on being supported through time, which is great. So why do we care about .NET? So my background is as a .NET developer and a Microsoft app developer. So I started with Visual Basic years ago. I've worked with C# ever since it was released. I've always worked in and around data, so a lot of work with SQL Server and like building data pipelines and things like SSIS and writing console apps. And then around, was it 2017, Databricks was released on Azure, and first project I worked on, I was completely captivated by Spark, like the simplicity of it, the performance of it. Ever since I've started using Spark, I haven't had to look at a SQL Server execution plan or worry about table statistics. So that's great, that's perfect. But the sort of downside really is being forced to sort of migrate over some Python. Like every data engineering project I've worked on pretty much has mostly been in Python since then, but I'd rather work in .NET. Microsoft say there's about 5 million .NET developers. Out of those, I would say there's a segment. It's probably a small segment based on the sort of low adoption that we saw in Synapse Analytics, but there is a segment of people who want to use .NET to connect to Spark, and I know of a few companies today using it today. So that's good. So that's really really interesting. That's why there are people out there who want to use it. So when I think about who wants to use Spark from .NET, I see there's sort of two broad categories. We've got on the left, we've got software engineers who've perhaps never used a data frame API. They want to make their own gRPC calls. They just want to get up and running, connect to Spark, send their like relations and expressions and their plans, get them executed. Then on the sort of the other side, we've got people who come from more of a data engineering background who want to use a data frame API. They've been using PySpark. They know how to create a job using data frame API, and they want to use that from .NET. And then sort of in the middle, you've got people who want to use a bit of both. And I guess probably that's where I sit out of all of these. So if we're looking at the sort of the software engineering side of things, what do we need to build like a bare bones client? Like what do we need to start up Visual Studio, start up Rider, go from zero to being able to run a job on Spark? So the first thing we need to do is we need to get the protocol buff files. In Rider and in Visual Studio, there's build actions, and those build actions will convert those proto files into like C# wrappers that create a client and the messages that you need to send requests down your gRPC channel. So we create those C# wrappers, we create our gRPC channel, we create our client, we create some relations. Optionally, we need to create expressions. We then create our plan and execute it. And if, say, your plan is to like read from one folder, one data lake, do some processing and write out to another, that's effectively everything you need to do. If, however, you want to collect the data back into your application, or you want to use like ShowStream or something like that, then what we're going to have to do is deal with the Apache Arrow data. But there is an Apache Arrow.NET library that's created by the Apache Arrow team that we can use. So there's a slight additional step, but you don't necessarily need it. So here we see, this is the proto file, this is the protobuf file, and that contains the messages, the requests, and the response that we're going to send backwards and forwards. So we need to understand this, and we need to convert this into C#, but that is handled for us. Then the next step is to create a relation. So if you were using like PySpark, you'd do like spark.range. This does a similar thing. So a relation here is akin to a data frame. So we create our data frames, and then we create our expressions on those data frames. So what we might want to do is create a with column. So we've got our range, which with like 100 rows. We then want to add another column. So we create a new relation, which is our with columns, and then we pass in whatever expression it is that we use to create that column. So in this here, we're going to create a string literal. So what we're going to end up with is we're going to end up with 100 rows. The first one's got the ID column from the range relation, and then we've got our string literal. And then we take that and we're going to create a plan from it, and we're going to here we're going to do show string. So this is going to send the plan up to Spark. It's going to generate the response. It's going to send us back a show string response, so we can display that in our console on the client side. And here what we have is a complete zero to sending a request off to Spark and getting a response. So if you don't want to use any libraries, you just want to make gRPC requests, this gives you everything you need. It will work locally, it will work in a POC. If you want it to work remotely in more of a production environment, there's obviously more work we need to do. Like we need to look at the responses, we need to look at if there are any errors, handle any errors, do that sort of thing. But if you just want to send data from C# to Spark, this will get you going. This is what you need. Now we have on the other side, we have like data engineers. Like, what is it they want? Like I don't think someone who's used the data frame API in the past is going to want to necessarily like work out, okay, how do I do spark.range? What's the relation I need to do if I want to add a column? What are the expressions I need to use? So what I've tried to do is I've created a library that has that data frame API that allows people to write code as they would do in PySpark, but just in C#. The idea really is to like just simplify the gRPC calls, like cover that up, make it easy for everyone so they don't need to use that, include things like error handling. But I suppose coming from the experience of like the .NET for Apache Spark project sort of coming to a stop, I didn't ever want to be a blocker to anyone. So I've made it so it's completely extensible. So if there's a function missing or something like that, you can easily implement it yourself by creating your own expressions and relations and passing them through to this data frame API, and then it'll work. I've tried not to use sort of any tricks, so there's no like reflection, there's no like objects popping up. So if you are on like the data engineering side and you go, okay, we need to know how to create the right plan to send up to Spark, then I'm hoping that they can use this project to see, okay, this function is implemented using these expressions, so they can sort of drill down and figure out what it is they need to do on their side to do it. With one of the sort of the main benefits really about getting the arrow batch as a response is that arrow is super fast. What happens is you get like a data buffer and you get a set of pointers to that. Now with the sort of default implementation of calling collect, I go through, I iterate the response, I create a whole load of .NET objects, and it's sort of like the antithesis really of what Apache Arrow is. Apache Arrow is, you've got your arrow response, maybe you write it out to a file, but it should be super efficient. So I've given like an alternative to collect as arrow batch, which is sort of the recommended to use really in this library. So you get that arrow batch and you can do what you want. You can pass it, you can write it out, you can do what you want, but without the overhead of having this other library go through and doing the passing for you. So that's really what the sort of the goals really are of the library I've created. It gives you a data frame API, and so we'll have a look at how to actually use it. So the first thing really is you just add the NuGet package, and then we create our Spark session, create our data frames, create anything you want to do like with columns on there. And if you're sort of familiar with PySpark, this should be very familiar to you. In fact, like I've got on the right hand side here, we've got some Python code, and on the left we've got .NET. And apart from things like Python, you can have like single quoted strings like F strings, and also like the naming. So we follow the .NET naming on the left and the Python naming on the right. It's extremely similar. So you could easily sort of copy and paste and make adjustments. And that's sort of one of the main goals really. Now the sort of like the sort of third persona really, or where there's like a function that you want to implement that's not implemented, I've made it really easy to sort of flip between the data frame API. So you see at the top, we create a data frame, and then we see in C#, you're creating your own relations and expressions and then passing them back to the data frame API. So the goal really is that we're never a blocker. you can always extend it in whatever way you want and keep going. And so, yeah, these are the key takeaways really. So Spark Connect is a supported API. So we don't have to deploy jars and do sort of translation and proxy requests backwards and forwards, which is a massive thing. I mean, the main thing really is that they're always playing catch up with Spark. Spark would release a feature and then we'd have to go and implement it. But now we can just sort of work and keep up to date with features as they come out. If you want to, you can just completely make your own gRPC calls. You don't need to use any libraries. You can just get up and go, and that's fine. There's more work to do, but it's completely viable. If you do want a data frame API, we've got a library available for you. If you want to make your own gRPC requests and understand how things are made, then you can use this library to have a look and work out how to build your own plans. And the key thing is it can't be stopped. I can shut down the repo tomorrow and you can just carry on without any problems. So yeah, that's it. Thank you.
Well, thanks a lot for all three of you for a very instructive and in-depth conversation about Spark Connect, how people actually get started. We have a few questions that actually come in. Martin, you answered some of them already about, what happens when somebody sends out multiple transformations. Do you actually collect them together, or do you actually have one transformation when you do an action? I believe you answered that question. Maybe you just want to summarize what it actually means in the sequence of how the logical plans are created and how, when the action is performed, you send one large logical plan. So could you clarify on that for the rest of the audience?
Sure, I can do this. So one of the interesting things is that if you let's compare a little bit like how PySpark works and like Spark today. Essentially, when you're creating doing any data frame operation in PySpark today, then essentially you're always talking to Spark and you're building up the logical plan and you're calling analyze on it essentially to work in it. With Spark Connect, all of this is lazy. So this means when you're calling with column, nothing is really happening, nothing is sent to the server. And you're basically just stacking together different data frames. And I think that's this one of the fundamental pieces in this data frame stack is that each data frame itself is immutable. And by performing calling where or filter with column, group by, you're always creating a new data frame that you're stacking on top of it. And so as long as you're performing no action, nothing is sent to the server. However, now when you're calling schema, when you're calling columns, when you're calling collect, essentially, this is an action that then sends the plan over to the server where it's analyzed and so on. There are certain cases where, for example, if you're running in the notebook, the notebook always tries to run the string representation of a data frame, which in turn basically tells to the data frame, hey, can I please run df.schema to then give me a string representation of the data frame? This then means if you're doing this in a Jupyter notebook, every time you're creating a new cell, it will basically try to print this data frame. So it sends an operation. So in Spark 3.5, there were some, doing this caused a lot of reanalysis. And in Spark 4, we've actually added a plan cache to help with the frequent reanalysis of these plans to especially if you have repeated plans to avoid these kind of expensive operations. So this was one of the optimizations that we did to reduce some of the performance penalties that we've observed.
And those metrics, they normally come when you actually look at the Spark UI in the DAG, where you actually see the metrics. That includes also some of the Spark connections. And I've seen that in the UI.
Two sides of metrics. One is in the Spark UI. There's a separate connect tab that you can use. But what's actually even cooler in my personal view is every Spark developer runs a Spark fair and has ever asked hey, how do I know if this thing was fast or slow? So you always have to go back to the Spark UI, look at this thing and say how do I reason about this? So the cool thing what we did in Spark Connect is that every Spark query contains as the last message of the result stream a metrics object containing for each physical plan node how many rows, how many bytes, peak memory utilization, standard Spark metrics essentially. So I've built a bunch of hackathons where I think it's actually part of Spark as well. It's there's a 2-dot representation that allows you to basically create an SVG from a dot file. Dot is Gravis. It's a Gravis graph essentially, and then you can look at the query plan and it gives you all of the execution metrics. And all of a sudden you can see this queue in your join directly from your notebook without ever going to the Spark UI. And I think that's if anybody is wants to like contribute and like getting better, query observability based on that, that would be awesome. I think this is a field that is open for taking, because I don't think that, like this per query observability in Spark is that amazing at this point in time. Yeah. You're muted.
This question is actually, this question is meant both for Ed and Steve. I think Ed, you did a fairly illustrative job about how the three different personas can actually approach Spark Connect. One is a data engineer who just wants to use the data frame API and then use the .NET Connect, and then the data engineer who actually implements, some of those mimicking API for the Spark data frame. And Steve, you actually showed some of that. How much of both of you actually had to implement each and every Spark data frame to map to Rust and to .NET? Steve, you can go first.
Yeah, that's a great question. The data frame API is massive. There's a lot of aspects to it. But once you kind of get writing it, it's a lot of like rinse and repeat. Like you really start to understand exactly how things are working. Like you implement select, which is a projection. You implement filter, which and then where is the same exact thing. It's the same exact query plane. So once you start to kind of get going and you built the foundation that Ed talked about, where you have that client and you're starting to represent that plan and you understand that data frames are immutable and each one stacks, you can get going really, really quickly with this. There's a couple of little hidden things right there with how the client interacts, but like for the most part, like when you're actually developing out the data frame API part, once you kind of get the foundation there, you can go really, really quick. Like within Rust, we have macros, which are great, but also can be magic. I use macros to implement a whole host of the functions that exist within Spark. And that was really just like, okay, the name, the variables that need to be in there, the doc string, and then the Rust macro would just handle the rest. So I didn't have to like type in all the same boilerplate every single time. But yeah, it's kind of like building on the foundation, and then you kind of, once you get going, you can go really quick.
And Ed, to what extent you actually have one-to-one mapping between the data frame API and the .NET? Because I saw a lot of examples that actually show the comparison between C# and data frame API, and they look quite same semantically. I mean, I can look at the .NET or a Sharp code, and I look at the PySpark, and I say I can read it because I'm familiar with that. Was that intentional to make it look like as if it was actually PySpark, or was it just fell because of the way you implemented all the relations?
So it was definitely intentional. So I suppose there's two things. Like first of all, it's following like the .NET naming. So I've like renamed things, and like there's a lot of functions in Spark. But the things that helps, a lot of functions either don't have any parameters or just have one parameter. So like the hardest bit was trying to gather a list of what functions were there, what parameters they take, and then I generated a large percentage, say like 80, 85, 90% of them, and the rest was sort of manual. I suppose the one thing that's different from the PySpark API to C# is the thing I've struggled a little bit with is PySpark's got this concept of string or column, where you can pass in 3 or 4 parameters which are all string or column. In .NET, we don't really have that. We have objects, so we could just accept objects and then like check it one time, but it doesn't feel very .NET-y, C#. It doesn't feel very good. So I've created functions that take string or they take columns. But if there's like say 3 parameters, then they all need to be the same type. So there's a couple of differences that's not ideal, but I haven't quite found a good way yet in C# to express string on or column. We don't have union types, which would be perfect. So one day maybe, but not today.
I've run into similar things on the Rust side, just with how Rust likes to work.
A question for you, Martin. I think this might be something that you might be familiar with. I mean, is it possible to use the MTLS with Spark Connect? And I'm assuming he's referencing to something with the proxy.
Right, exactly. So I think there was another question as well about like authentication in Spark.
Yes.
So I think like one thing that we have to understand here is that Spark itself doesn't really come with a lot of like built-in authentication and authorization mechanisms. Like this, it's a problem that gets solved somewhere else. And I think what we've been observing is obviously in Databricks like we have our own stuff, but I've been working on something called Spark Connect Proxy. I can put the GitHub link to the open source project in the chat as well, which is essentially a reverse proxy for Spark Connect, and not just for one Spark Connect service, but like the folks that remember Livy or to degree QB, which operate kind of like, hey, I want to basically load balance across a number of like Spark clusters. I want to manage sessions. So basically, I started working on this project, which gives you the ability to basically, like connect to a bunch of different Spark clusters behind the scenes and run queries and like have a central endpoint. And you can configure TLS on this endpoint. And you like the way that this set up is like gRPC middleware that now I want to extend this to, okay, how can I bring in custom authentication middlewares, and then basically integrate this into existing infrastructure to say, okay, I want to use OAuth, I want to use whatsoever. It all terminates at this proxy and then gets like delegated to the necessary Spark cluster. So this is work in process. Like please feel free to contribute. I'll put the link into the chat channel here. Feel free to ping me on this one. I'm looking for contributors as well on this one. And this will solve, some of these kind of like, how do we deploy this in particular for remote connectivity?
Right. And that solves the token authentication problem, right?
Exactly. So whereas like, again, like Spark doesn't really know about tokens. Like we use this because it was like convenient for us. Like Bearer token is a very standard way of authenticating. And you can configure Envoy as a proxy as well. You don't need necessarily like this project, but the problem is always like, well, like Envoy only like maps to one backend. So that's why I think such a proxy like that's similar in spirit to QB is like actually, or Livy is like the best possible approach.
Steve, I mean, in your demo, you actually showed how you're actually collecting the kernel stats from, your local file system, whether you're using /proc to read those. Were you actually using streaming to be able to write something, or was that Rust implementation actually incorporated the streaming API?
So that actually just creates an arrow record batch on the computer, and then that's what creates the data frame for Spark, and then it sends that off to the server. So it's like a local data frame, but then it's joining with some data frame that's actually on the Spark remote cluster, and then bringing that all in and showing it on my computer, on the fake edge device that I made, which is just my computer.
Okay. So you can actually simulate some sort of a streaming, which obviously Spark supports, and that way, for the user, it's completely seamless whether they're using Spark Connect or not. For them, they're just using Spark data frame APIs for streaming perspective. Ed, there's another question that came up, and I don't know how extensive that is. Can you actually use C# on Windows VM? Can access Databricks?
Yeah, absolutely. So if you connect to Databricks, you need to, the two approaches. You can either make the gRPC calls yourself, you need to include like authentication, and the sort of the loop of requests and responses is slightly more complicated, especially in Azure. You instead of using execute, there's a thing called execute reattach. So you're going to definitely want to use that, or you can use a library, and that I test that. Every build gets tested with Databricks on Azure today, so that definitely works. And you can use that as an example if you don't want to use a library, but you can see what you need to do to implement it.
Now, one of the things that actually Martin emphasized in one of the slides was the huge merits of using Spark Connect is the ability to actually debug your code, right? Yes, you could actually debug Spark code initially. You have to do it, attach a process to a particular local machine, and then you step through the code. So one of the benefits over here is Spark Connect debuggability. Martin, could you briefly sort of elaborate on a little bit about the debugging capabilities in Spark Connect and how is it different from the traditional one, right, and to what extent you can actually go through stepping through each and every operation. For example, can you step into a UDF, or can you step into a data frame transformation?
Right. Yeah, I can do this. So fundamentally, like the goal, the debuggability that we want to bring is like not debugging Spark. Well, it's usually like nobody really needs to debug. Like, oh, well, did my RDD? I mean, the underlying RDD essentially of my like table scan like partition correctly and like debug through this. I mean, this like if you're developing Spark, yes, maybe. But if you're just like running your Spark, you don't. So what Spark Connect offers you is by being able to run the driver application essentially locally, gives you the ability to use your local development environment, your local IntelliJ, your PyCharm, whatsoever, and simply, like set breakpoints and like step through your code. And you can debug essentially the code that drives the Spark application. This is very similar to essentially as if you were debugging an application that uses a JDBC driver. And that sometimes when we're referring to Spark Connect, we're saying like, hey, this is like JDBC on steroids. Why? Because it can do like so much more. Because again, like the cool part about this is if I like the way that data frames stack, well, I set a breakpoint and I can basically look at a data frame. I can like get the schema of it. I can collect on it. It's basically an object that I can interoperate with that again, like lets me like talk to Spark. I can like assign this to variables and like just compare like the in and output of these two things because, like the data frames itself are immutable. So like if I have certain transformation logic, I can check it like, hey, why does this no longer give me the same value? I can like live interact with the system. I think this is this kind of this benefit that the debuggability brings is that I can reason about my application state while the application is running. And I think there was a question here about like that goes in a similar direction of like long running Spark apps, like complex state machinery. So again, like keep in mind that today when you're submitting a Spark app, essentially, you're submitting your code into the like coordinator of the Spark cluster. And I think the biggest benefit is that you're separating out the failure states of your own application from Spark. So conceptually, you want to prevent that, hey, if my code brings Spark down, because that would be bad. And you want to control the fate of the system in that way. And like we're not changing the way that Spark runs. We're not changing the way how the state machinery works. But essentially, we just like want to provide better isolation for the actual like application that drives your ETL workloads. And like submitting Spark apps using Spark Connect like remains possible in the same way. That's what I meant with like this one API conf to rule them all. So like going forward, you can just do like Spark submit my Python job and then set --conf Spark API mode connect, and then it will use Spark Connect behind the scenes, no questions asked. Like you don't really see any of this. And I think this is really the beauty of it, that we want to make this transition very seamlessly. We want to make sure that it's very easy to do and nothing really that you as the end user, as long as they're using data frames, you don't have to worry about this.
A similar question to you, Steve and Ed. Did you actually have to use an IDE to step through your Rust code, or were you resorting to printf statements?
I am a hack and I love some printf debugging. I'll admit that. No, but it is helpful on the Rust side, so we can actually kind of like debug and set those breakpoints as I was building on the client to figure out like if I wasn't handling the message that came back from the server correctly, I can actually see like, oh, it's sending multiple messages back as part of this stream when I was submitting some type of job. But yeah, you can still do that and kind of like step through things with your different IDs that you have.
I think this is the general question, but any one of us can answer. If I have an existing PySpark job that runs on EMR, would the only benefit in migrating to Spark Connect be serialization performance?
I think it's look. I think the way that I usually when I talk to customers and users in the community, when I get the answers questions like, what's the benefit of never touch a running system? It's like it's the number one thing that every basically developer gets like taught. It's like never touch a running system. And I think like that's why I think our goal with Spark 4 is essentially to look forward. It's not to change the existing infrastructure and force you to adapt all of your existing code. No, it's making sure that if you're starting to develop new workloads, how do I make sure that you're benefiting from the benefits of Spark Connect in the future? So I wouldn't say it's necessarily about performance, but it's about upgradability. I think this is this one thing where I say like, hey, this is kind of really important because, with Spark in the future, how do I make sure that I'm ready for Spark 5? Like there is like we've talked in the community, like, hey, how do we avoid like having like a 3-year break between major releases? We want to have more frequent releases. How do we make sure that like we don't force our users down like all this kind of like upgrades? And I think this is one of the biggest benefits that Spark Connect brings, is that even if you don't care about remote connectivity at all, just the separation of concerns of your client code from the rest of the system gives you benefits that you will use long term, essentially.
Yeah, I mean, I think that's a very salient point, is that we are not actually forcing down people's throat that you have an existing traditional RDD workloads that you have to, that you must, as Martin pointed out. If something is working, don't break it. But the important thing is looking ahead where the Spark is actually going, and especially with the ability of Spark to be able to have access from non-JVM clients, which you actually just saw today. Steve showed about Rust, Elliot showed about .NET, and there are a few things be developed. There's one, Graph Frames now actually has a connectivity client, so you can actually use Graph Frames. PHP, and I never heard about somebody would want to use PHP, but they do have a PHP client that actually talks about Rust. So I think it's the ability of Spark accessing from all these other edge devices along with non-JVM language, and I think that's the important thing that Martin pointed out is the future where we're looking at. Now, a general question, I think we have about 5 more minutes, but a general question to all three of you. I have a language called X, whatever you want to call it. And I want to actually somehow create a Spark Connect client. What would be my first steps? Where would I actually go to figure out how to actually do it? What would be my first step? Do I have to understand the gRPC protocol buff because I'm converting some relations and I'm mimicking the data from API? How would I actually get started? Ed somehow showed that personas, but generally speaking, in grand scheme of things, from Steve, from your point of view, how did you actually go about doing that? Maybe you can point out. Maybe Martin, you can talk about in general how to get actually started.
That's a great question, especially if you kind of want to like take on this in another language. Myself, I interact with Spark almost every day with my job, and I always leverage it from the Python side. So when I really started to look at this, what I was looking at was I just started to step through the PySpark side of this and see, okay, when it's connecting, what is it doing? What are the libraries that it's there? And then going on the Rust side of the equivalent side of this and saying, okay, what's the gRPC package for or library or crate for this, and okay, it's using Arrow and taking those back. So I started to just kind of like step through that on the Python side to kind of like really understand that. But then that takes you on the journey of like, well, now I really got to understand how the Rust crate for gRPC works. And now I got to really understand how the Arrow crate works for Rust. And it takes you on this really great journey if you start to learn through all these different things you may not have been aware of, especially if you just are from a data engineering perspective, if you're just interacting with Spark, you get such a depth of understanding now about how this actually all works together.
So, Martin, when you talk to customers who actually want to say, okay, I have this particular language and I want to convert, would you give them the similar advice? Tell them, oh, go to this particular documentation, or look at the source code, how we did that. What would be the best way for them to, get a leapfrog ahead to understand that?
Right. I think, look, I have two hats. Well, I have like the open source Spark Connect hat, and I say like, please build more languages, everybody benefits. And then I have like obviously my Databricks hat, and I say like, hey, like, you please make sure that you know what you're signing up for. I think what Steve says makes a lot of sense. It's like if you have the urge, and I think like if it solves a need, right? I think like for example, Spark Connect Swift is one of those cases where it's like, hey, because I have this, I use a Mac all day long. So for me, basically, I've always wanted to have a Mac app native Spark Connect. Now I can build it. And I think like, and I tried like, hey, can I build native bindings in like Swift? And I was like, yeah, not really. So I think that's cool. And I think this is really like using the Python as a reference implementation, on the Scala one as a reference implementation, and understanding there are two layers. One is the data frame abstraction. That is like the logical translation of like the way how the user interacts with it, and the client, which is essentially responsible for like sending and serializing the plans. And like once you get a hand on like both, it's not, I don't think it's necessarily a crazy complicated effort. I don't think it takes like years to build a new language client. It's mostly, it's a couple of months, right? Because the vast majority of the problems are solved somewhere else. And I think this is very much in the same way. What does it take to build a new, like SDK client for X, in a new language? Well, there's a defined protocol. There's like reference implementations. There's like the API is defined. Like you don't have to reason about like, oh, does data frame, is it called filter or filters or with filter? I mean, sure, there's some language idiomatic pieces, but fundamentally, all of these things are solved. And it's really just like hammering out basically, oh, this looks the same, so let me do this. Actually, I mean, I use like Copilot a lot for some of this stuff. This is, this is where Copilot shines. It's like seeing this repetitive code that you're writing that's just like this kind of like almost boilerplate like, but not really. Like it lets you advance pretty fast, I would say.
I mean, talking about Copilot, I was testing some of the Spark Connect with 4.RC, and most of the code, I asked actually Cloud Sonnet to say, I want to write a Spark Connect API to do this particular transformations, and I want to do all this thing in a sequence. Can you generate some code? And he actually generated Spark Connect code with a remote thing, and I was quite surprised. So it probably has the latest knowledge of what Spark Connect. All I need to do is just have one remote in my Spark session, and now I'm talking to my Spark Connect on the local host. And I was quite impressed, and everything just worked like a charm. So that was brilliant. I think we are out of time. I do want to thank Steve. I do want to thank Martin, Ed, and Carly for making this happen. Thanks a lot for very lively and very instructive information about Spark Connect. Hope you guys to join us in about a month. We're going to be talking about Spark 4.0. Again, there'll be mention of Spark Connect there too. So join us, and thanks a lot for all of you, and have a good evening and good morning, and enjoy yourself. Spark Connect, way to go. Cheers.
Thank you.